Radio-controlled model jets first flew onto the radar in the 1970s and have since evolved into sophisticated flying machines. Many have turbine engines and use real jet fuel. They allow people who would otherwise never pilot a jet to experience the thrill of flight with both feet on the ground. Radio-controlled model jets can roll and dive like actual jets. And they can reach speeds of up to 280 miles an hour. Operating one isn't child's play. It takes practice and skill to pilot this kind of model aircraft. It also takes money because they cost up to $20,000. Making a model jet begins with the paint job. They airbrush designs directly into the molds that will be used to shape various parts. This particular mold will be used to make one half of a wing shell. When the paint dries, they roll epoxy resin into the mold. Then put down a layer of fiberglass. They reinforce the fiberglass with super strong carbon fiber. Then brush on more epoxy resin. The next layer is balsa, a lightweight wood from South America. They apply carbon fiber to sections of the wing where parts are to be attached. Another sheet of fiberglass and epoxy is the final layer. Now they add a layer of absorbent material, then sandwich the mold in plastic film. They install a connector for a vacuum hose and hook it up. The vacuum pulls out the air, squeezing the layers together. Then they bake the unit, which activates the epoxy, fusing the materials together. Next, they assemble the wooden framework for the wings. They reinforce it with strips of carbon fiber and apply epoxy on the edges. The model makers carefully install the framework on the wing shell. They apply an extra rib along the wingtip. Slide aluminum cylinders into tubes in the framework, then bead more epoxy along the wing shell's perimeter. They use high-strength adhesive in strategic parts of the framework to attach the other half of the molded wing. They bolt the molds together and set the assembly aside to allow the epoxy to cure. After a few hours, they extract the wing. Its artwork nicely transferred from the inside surface of the mold. Machinery then cuts holes in the wing for installing landing gear and motors called servos. This router is computer programmed to make perfect cuts without damaging the internal framework. This is critical because just a fraction of an inch off and the router would destroy the carefully crafted wing. The modeler now perforates the fiberglass layer of the wing. He's creating a hinged section called an aileron. It's a control surface that will cause the plane to turn or roll. The ailerons and other control surfaces will be powered by servo motors. The front fuselage shell has been molded and is now ready to be revealed. Like the wings, the body of this model jet needs a supporting framework, along with brackets for attachments. Another computerized router carves them out of multi-layered carbon fiber board. The modeler glues these parts inside the fuselage and the tail of the jet. Coming up next, this model jet gets its wings and prepares for takeoff. Controlling one of these jets is challenging and requires concentration. These are expensive toys, and the learning curve is steep. One bad landing, and this model jet could end up in a crumpled heap. It's why flyers hone their skills at airfields and test them in international competitions. Back at the factory, the molded pieces of this model jet are coming together. They attach the wings to the fuselage, using the cylinders installed earlier. Then, the modeler moves to the aircraft's tail and attaches the stabilizers, the rudder, and the vertical fin. Super strength glue cements the assembly. Next, they build the motor. This one is a ducted fan electric system, a type used in smaller jets. The modeler first assembles the casing that will hold the fan and its motor. He slides airfoils into the casing to create 4 ducts, which will properly channel the flow of air. He slides the electric motor into the aluminum hub. Then anchors the assembly with a screw from the other side. The next part is a speed control mechanism. He solders its wires to those protruding from the motor. He encloses the mechanism in a vented tube, then sets the assembly aside temporarily. Now, focus turns to the fan, which he hooks up to a testing device. As the fan spins, the machine analyzes it for vibrations that would indicate the blades are out of balance. The gauge shows it's vibrating slightly, so he makes adjustments, and then it's ready to install. He attaches the fan to the motor shaft and secures it with a bolt in the center. It's now time to power up this motor at a test station. He brings it up to full throttle and measures the thrust it generates. It passes the test, so he installs it in the model jet's fuselage. Later, this ducted fan motor will be connected to a battery pack. Now he moves on to the landing gear and attaches air cylinders to the front and rear wheels. Pumping air into these cylinders will cause the wheels to retract after takeoff. This system will also cause the wheels to engage for landing. Next, a sheet of clear thermoplastic is transformed into cockpit canopy parts. A machine heats the plastic, then vacuum shrinks it to 2 molds. The plastic hardens in seconds to create 2 clear plastic bubbles for the jet canopy. They mold the cockpit shell in 2 sections using the same technique. With the cockpit now installed and a dial for a pilot, this 50s-era Korean warjet replica is in fighting form. All that's left is to install the radio control system, which will be done by the operator after purchase. From nose to tail, the attention to detail is impressive. Some of these model jets even have gas turbine engines for added authenticity. With radio controls installed, this turbine model jet is ready to taxi down the runway. The operator does one last check of the control surfaces. Then it's time for takeoff. Miniature turbine engines sound and work like those of a big jet. These jets rumble and soar and can be made to perform many aerobatic stunts. Of course, it all hinges on both the skill of the operator and a job well done at the factory. But this looks like another successful landing.